Okay, so today we're diving into something pretty cool.
Yeah.
Could another Earth, using the tech we have right now, could they actually spot us? And we're not talking, super advanced aliens or anything.
Right.
This is about civilizations like ours, what they pick up on. We're using a new paper for this. It's called Earth Detecting Earth. Very clever title.
I like it.
It breaks down Earth's technosignatures all across the electromagnetic spectrum and all that.
It makes sense.
So picture this.
Yeah.
You're on that other Earth, looking through a telescope. What's the first hint that humanity's here?
Well, the first thing they'd probably notice would be our radio emissions.
Radio. Huh.
It's really no surprise that SETI, the search for extraterrestrial intelligence,
Well, of course.
started with radio waves.
It makes sense.
They're strong, they travel far, and we've been using them for over a century.
So, my favorite late-night radio show, that's beaming out to aliens right now.
Technically, those signals do leak into space, yeah. But they're not the kind that'd be easiest to pick up. The paper focuses more on intentional signals, like planetary radar.
Planetary radar.
Think of the Arecibo Observatory. It's not around anymore, sadly.
I remember hearing about that.
But when it was, it would bounce radar signals off Venus.
To what? Map it out?
Exactly, map the surface.
Oh, no.
And those signals, they're way more powerful and focused than, a radio broadcast.
Gotcha. So how far out could those radar bursts travel? If someone was listening, how far away could they be?
Well, the calculations in the paper show that those Arecibo-type signals could theoretically be detected from, get this, up to 12,000 light years away.
12,000?
Yep. For perspective, that's almost the entire width of the Milky Way galaxy.
Wow. That means even if, smart life is super rare, our signals might be hitting someone's antennas right now, right?
You'd think so, but there's a catch.
Yeah.
Even radio waves traveling at the speed of light are, limited by that speed.
Oh, right, of course. So those signals, as strong as they are, they haven't actually traveled that far yet.
Exactly. Those Arecibo signals, they've only gone about 50 light years out so far.
So it's like we're creating this bubble of radio noise around Earth.
Kind of.
And it's slowly expanding, revealing us to anyone inside as it grows.
Yeah, like a ripple effect.
Cool. But what about the less powerful stuff, like the signals we use every day for space probes and things like that?
Even those leave a trace. Signals from NASA's Deep Space Network, the one that talks to Voyager and all that.
Right.
Those could be detected from about 65 light years out.
So every time we're like, hey, Voyager, how's it going?
Haha, basically it's like a little cosmic whisper saying, hey, we're here.
It's wild to think every time we explore space, we're making this fingerprint of humanity, spreading out further and further.
That's a good way to put it.
But radio waves, that's not the only way to find us, right?
Yeah.
Does the planet itself, does Earth give off any clues that we're a tech-savvy bunch?
Actually, yeah, it does. The atmosphere itself carries some telltale signs, even if they're subtle.
You're talking about pollution,
right? Okay.
Is our smog like a giant billboard saying, humans live here?
Not quite that simple, but it's on the right track. Certain pollutants, specifically nitrogen dioxide, NO2.
NO2.
Yeah, that can be detected with the same tech we're developing to find life on other planets.
Whoa, hold on. So looking for aliens is teaching us how to spot alien technology.
Exactly.
That's pretty cool.
It is. The tools we use to study exoplanet atmospheres, looking for biosignatures,
Right.
Well, those same tools can also find technosignatures, what we use to look for oxygen, methane, the things that say life might be here.
Right.
That can also spot the chemical leftovers of industry.
Okay, I'm going to need an example here.
Sure. So nitrogen dioxide, it comes from a few places. Natural stuff like volcanoes, some biological things, microbes and all that.
Okay.
But it's also a big byproduct of human industry, burning fossil fuels in cars, power plants.
Right, makes sense.
So if you were to look at Earth's atmosphere, you'd see a higher level of NO2 compared to a planet that's, not industrialized.
So future telescopes, they could actually see if another planet is polluting like we are.
Yeah, exactly. The paper suggests that telescopes like the Habitable Worlds Observatory that's coming up,
I've heard of that one.
that could see Earth-like levels of NO2 from planets that are, about 6 light years away.
So basically, in our little corner of the galaxy,
Uh-huh.
we could sniff out other civilizations by their smog.
Precisely.
It's kind of a bummer that our pollution problem is literally a cosmic beacon.
I know, right?
Speaking of spotting things from far away, what about a classic sci-fi idea? City lights.
Ooh, Ooh, yeah.
Could we actually see alien cities lit up on another world? Like, for real?
That's where it gets a lot trickier. It's a cool idea, but spotting city lights across interstellar distances,
Yeah.
it's really, really hard with our current tech.
But we've got Hubble, James Webb. Those are crazy powerful. Couldn't they at least see a few bright spots?
Even with those, it'd be super tough. The paper says to see city lights like ours, you'd have to be ridiculously close.
Like, how close?
Like within our own solar system's Oort cloud close.
The Oort cloud. Isn't that, like, way out there?
Way out there, yeah, way past Pluto even.
So no spotting alien Times Square from across the galaxy then?
Yeah.
Bummer. But I thought I read something about certain streetlights being easier to see than others.
You're right. There's a little hope with sodium lamps, those orange-yellow ones they use a lot in streetlights.
Oh yeah, the old school ones.
Those put out a very specific kind of light, a specific spectral signature.
Uh.
It makes them a little easier to spot if another civilization's using them.
So if their cities are lit up with those sodium lamps, we might have a chance?
It's possible, but still a long shot. The distances are just immense.
Yeah, true.
Even those lamps would need to be super bright and everywhere for us to see them from light years away.
Okay. No alien skylines lighting up our telescopes just yet.
Ah.
But what about lasers? I mean, we use them to talk to spacecraft. Wouldn't those be easy to spot across space? Like, could those be a beacon?
Lasers, yeah, those are interesting for sure. Systems like NASA's Deep Space Optical Communications,
Oh, yeah.
those are incredibly powerful.
I bet.
But spotting them, even at interstellar distances, is really tough.
I would have thought lasers, so focused and all, would be perfect for talking cross space.
You'd think so, right?
Yeah.
But it's not just the laser itself, it's also about, like, separating that signal from the star it's orbiting.
Oh, right.
Imagine a firefly next to a spotlight. That's what we're dealing with.
Yeah, that makes sense.
The laser signal, even a strong one, gets lost in the glare of the star.
So it's about contrast.
Exactly.
Okay, so how do we get around that?
One way is using something called coronography.
Coronography, what's that?
It uses like special instruments to block out the star's light directly so we can see fainter things around it.
Kind of like putting your hand up to block the sun.
Kinda, yeah. It's similar to how we find exoplanets too. You dim the star to see the planets better.
So the same tech to find planets helps us find lasers too.
It's cool how stuff in one part of astronomy can help out everywhere else.
Totally.
Yeah.
But even with that coronography thing,
Yeah.
detecting another civ's lasers, that's still got to be a long shot.
Oh, yeah. We'd need super sensitive stuff. And honestly, some luck, too.
How so?
We'd have to be looking in exactly the right spot at the right time. That laser would have to be pointed right at us.
Oh, so they have to be trying to contact us on purpose?
Basically.
Okay, so
Yeah.
we've got radio signals, pollution, city lights, lasers.
Yeah.
It seems like everything's got its own problems.
It's true. It's tricky stuff.
But what about the things we've sent out? Satellites, probes, even the space junk. Wouldn't that be detectable?
You're right. We've left a lot of stuff up there.
It's like our cosmic trash.
In a way, yeah. And that stuff could be a technosignature, too.
Not as exciting as alien cities or laser beams, though.
Maybe not, but it's still a sign of our presence.
So how would we even detect that kind of stuff? Like a broken down satellite or something?
Radar's our best bet for finding things in space.
Radar, like what we talked about earlier.
Exactly.
But didn't we say radar doesn't reach that far?
It depends on what you're looking for. It's good at detecting objects, but for smaller things, its reach is limited.
Yeah.
The strength of the radar signal, it drops off pretty fast the further you go.
Didn't Arecibo use radar to find a lost satellite once?
It did. It was pretty amazing, actually. It showed how we can use radar for a kind of space archaeology.
Space archaeology.
Digging up our past in space.
I like it.
But that satellite was still pretty big, and within our solar system, something tiny light years away, that's a whole different story.
Okay, so satellites are hard to spot. What about something on a planet's surface?
On the surface?
Yeah, like we've got rovers on Mars, the landers on the moon.
I see what you're saying.
Wouldn't those stand out? Metal against the dirt and all?
It's a good thought, and the paper even talks about that, using the Apollo lunar modules as an example.
Oh, cool.
They're about 4 meters across, mostly metal, so they contrast with the moon's surface.
Shiny metal thing against a dark background.
Exactly.
Makes sense. Can our stuff orbiting the moon see something that small?
The Lunar Reconnaissance Orbiter, it's got a high-res camera.
Good.
That's our best bet. It can see things down to, like, half a meter.
So it could see a lunar lander then?
Theoretically, yeah.
Okay, phew. At least we can keep track of our own stuff. But if it can see that small, why not use it to find things on planets around other stars?
Distance. Always distance. Even with great telescopes, seeing something lander-sized on a planet light years away, it's like trying to read a newspaper from miles away.
Yikes. Everything comes back to distance, huh?
Pretty much.
Space really makes you feel small.
It does.
So we've done radio, pollution, city lights, lasers, satellites, even stuff on planets.
Yeah.
Anything we've missed.
Well, there's one more idea. I haven't touched on it yet. The Clark Belt.
A Clark belt, what's that? Sounds like a sci-fi.
It's a hypothetical ring of satellites, all in geostationary orbit around a planet.
Geostationary?
Meaning they stay over the same spot on the planet.
Oh, I see.
So picture it. Tons of satellites making a band around the planet's equator.
Like a giant necklace.
Yeah, something like that.
But how could we see that from far away? It'd be tiny, right?
Right, it'd be really tough. The paper says maybe if it's super dense, we could spot it by how it blocks the star's light when the planet passes in front.
Hold on. We'd see a ring of satellites by how much starlight they block. That's got to be a tiny amount.
It is, super tiny. With what we have now, seeing a Clark belt like Earth's, basically impossible.
What makes it so hard? Are our telescopes just not good enough?
It's partly that, but also how many satellites there are. Even with all our space junk, Earth's orbit isn't dense enough.
So we need way more satellites closer together to make a noticeable difference in the star's light.
Yeah, way more.
Okay, so no alien Clark belts on the horizon yet. But maybe someday, with better tech, we could find those too.
You never know. That's the exciting part.
It's crazy, all these limitations.
It's humbling, for sure.
We've covered so much. Radio waves, atmosphere stuff, city lights.
Lasers, satellites.
My brain's kind of fried. Can we, sum it all up? What's the takeaway here? What does it all mean for us, in the grand scheme of things?
Good point. Let's try to simplify it. Even with all these technosignatures, there are some clear patterns.
Okay, like what?
First, radio astronomy is still super important for finding ET.
Still the best way to find them, huh?
Especially if they're at a similar tech level as us.
But what about those other technosignatures? Are they worth looking for, even if it's hard?
Absolutely. While radio might be the best for long-distance calls,
right.
the others tell us about how civilizations impact their environments. It's a bigger picture.
Not just finding a signal, but understanding what kind of civilization made it. I gotta be honest, I'm feeling kind of small right now.
Yeah.
Our best signal barely reaches across the galaxy, and everything else is basically invisible past our solar system.
I know what you mean.
It makes you think, are we really that significant?
It is a humbling thought.
Like a tiny blip on some cosmic radar, barely noticeable.
It's true, our technology is impressive, but our mark on the universe is still pretty faint.
We've only been doing the radio thing for 100 years.
A little over that, and the other stuff, even less time.
It's like we're just starting to make a splash in this huge cosmic pool.
That's a good way to put it.
So are we destined to be this silent, invisible planet? Is it even worth trying to make ourselves known with all these distances and limitations?
Not necessarily. The paper makes a good point.
Yeah.
We might not be shouting across the galaxy yet.
Right.
But we are detectable, at least in our neighborhood.
So someone close by could find us.
Exactly. And the cool part is, as our tech gets better, we'll become more visible, Yeah.
So it's not hopeless. But what kind of new technosignatures are we talking about? What'll our cosmic fingerprint look like in 100 years? 1,000?
Now that's fun to think about.
Right.
It's all speculation, of course. But I bet our future technosignatures, they'll be even wilder and more diverse than what we see now.
Like what? Give me some examples.
Well, maybe we'll figure out how to use the power of stars directly, or create wormholes, or even mess with space-time itself.
Okay, now you're just showing off.
Haha. But you get the idea. Those would be some serious technosignatures.
Yeah, no kidding. But let's get back to reality for a second.
Sure.
This paper, it's about what we could detect now.
Right.
And it's kind of mind-blowing.
How so?
That our radar's reaching thousands of light years, that's crazy.
It is pretty far out there.
But also, most of what we do is only visible right around us.
It's true. Our reach is still pretty limited.
Yeah.
But it's not just about the distance, right?
What do you mean?
It's also a reminder of how tricky this whole technosignature thing is.
Yeah, good point.
But it also shows why we gotta keep exploring, keep pushing the boundaries.
Because the more we learn, the better we get at finding stuff.
And the more we invent, who knows what new ways we'll find to make ourselves known to the universe.
True. So we end up with more questions than answers.
I guess in a way, yeah. But that's how science works, right?
Yeah, I guess so.
Every time you figure something out, it opens up even more things to figure out.
Like we're peeking through this tiny keyhole, seeing a little bit of this massive universe.
That's a great way to put it.
But we can only see a tiny fraction of what's really out there.
For now, but as we keep going, that keyhole gets bigger, we see more of the picture.
I like that. Well, this deep dive, it's really made me think
Me too.
that we're part of something huge, a story that's still being written.
And who knows, maybe out there,
Yeah,
someone's looking through their keyhole and they'll catch a glimpse of us.
that'd be amazing.
It would. And as we get better at hearing those faint signals,
Those whispers of technology.
maybe someday we'll actually meet another intelligence, share our stories.
Across all that space and time.
Exactly.
That's a great note to end on.
Okay.
Until then, everyone,
Keep looking up.
keep asking questions.
And keep exploring.
And never stop wondering what's out there.